Welcome everybody. I was asked to, just a general question actually about recognizing things on the graphs for today's work, or for last day's work I guess. So I'm just going to kind of talk through, if I was looking at this question, what I would be seeing and what I would be thinking. So the question basically is match these equations with the graphs below. There are a number of things I can match, but the first thing to sort of notice is when I look at these, I do see I sort of notice the degree of the function first. That's kind of my go-to. That first term on any function, any polynomial specifically, is always by far the most important. It establishes the basic shape of our graph. And so without even kind of going too much further, I can see a fourth power, a fifth power, and a sixth power equation for each, or in the three options. And so if I look at just this first graph, I can see my graph goes 1, 2, 3, 4, 5 different directions, which means that it is going to be a degree 5 or higher function. And when I say degree 5 or higher and odd. So right off the bat, I know that's going to be this question here, or this equation here. Similarly, looking at the others, I need one that's going to go 4 directions, one that's going to go 6 directions. So if I just kind of count here, I'm seeing 1, 2, 3, 4 directions. Okay. And 1, 2, 3, 4. Oh, drat, that's not good enough. So again, key here being, when I said on the first one that this was 5, I did say or potentially 7, 9, and so on. So with our degrees, the degree establishes the maximum number of directions that graph can go. So with the x to the fourth power here, I can go up to 4 directions. With x to the sixth, I can go up to 6 directions, but just depending on what other values I have in my expression, I may not go all 6 directions. So now I got to look at a little deeper. There are a couple more things I can look at. The first of which is the leading coefficients in each of the two cases. So in the first case, I have a 0.5, a positive number. In the second case, I have -1, a negative number. And so if I know my graphs well, I know that my fourth power looks basically like this, unless it's been flipped. My sixth power, again, kind of looks something like this, unless it's been flipped. So with the positive in front, I do know that this is graph I, and with the negative in front, this is graph III, or 3. Now, if I don't know that, that's okay. If I don't sort of have my graphs memorized, I should never have to memorize things when numbers are really involved. What the graph, or what this first term establishes for me, is what happens on the two ends of my graph. And so if I didn't know which one was which, still by just seeing the fact that one had negative, one had a positive, I want to understand that I'm interested in what's happening when I look at different x values. So on the left side of my graph, I'm looking at numbers like x is -10, or really x is, something more like this. But what I'm trying to establish, or what I need to establish basically to compare these two graphs, is on that left side of my graph, are my values going up to positive numbers or coming down to negative numbers? What are the y values I get in each case? And to do that, I can simply plug some sort of negative value in for x. So if I look at that first equation, I've got 0.5 x to the fourth. When I put a negative number in here, and it doesn't really matter what that negative number is, although I'm really interested in what happens way out to the left, hopefully we can see I'm going to have -1,000 to the exponent 4. So -1,000 times -1,000 times -1,000 times -1,000, basically a bunch of negative values multiplied times the positive number out front. And so that will be a positive value. So if I didn't know which graph was which just kind of by having known the shapes, I know that this one should have positive values out to the left. And that's what's going on here. Similarly, if I work with the other equation, I'm going to have negative the x value that I choose to the exponent 6. And if I put something like negative 1,000 in there, I have 1, 2, 3, 4, 5, 6 negative values. Oh, but wait a minute, there was another negative out front. And if I multiply 7 negative values, I end up with a negative answer, which tells me that the x to the 6th graph has to be going down here on the left. And I can think through the exact same things on the right as well. Now, if all of that fails in this case, there is one other option, although it's certainly the oldest option and the least valuable for our purposes in grade 12, but something we learned a while back. The constant on the end of any polynomial is my y-intercept. So in the worst case scenario this time, if I couldn't figure out anything else, I could go to that equation has a y-intercept, excuse me, of 4. This one down here has a y-intercept of 0. And this one up here has a y-intercept. You can't really see exactly, but in the, between 0 and negative 5, so it's the negative 3. So those are all things I should be able to see looking at the graphs and comparing with the equations. Question 9 is somewhat similar. Use each graph of a polynomial function to determine the lowest degree, or the least possible degree, I should say that, leading coefficient. So this is basically going the opposite way to what we just had. If we don't have the actual equations, what can we determine? And so we'll look at equation A here. Equation A, or graph A I should say, goes 1, 2, 3 directions. So it's going to have a degree of at least 3. Again, could be a 5, could be a 7, could be a 9. It has to be an odd number, but 3 is the minimum, and we're always going to just answer the minimum is the one we're looking for. The sign of the leading coefficient. So the question now is, what's the number in front of my x cubed? Is it a positive value or a negative value? So once again, if I don't know just based on looking at it, I can test a value in it and say, well, what if I had something like the negative 100 in there? Does negative 100 cubed give me a negative value or a positive value? It gives me a negative value, which means that down here, I'm going to have negative values naturally just from the x cubed, so I don't need anything in front of it. Or if I do have something in front of it, it would have to be a positive number because we don't want it to change my value. My graph shows that I should get a negative. The calculation with an x that is negative 100 automatically gives me that negative, and so any number out front that's going to be there would be positive. The x-intercepts and the factors of the function. Well, the x-intercepts are these values here. So I'm actually going to basically be putting my equation together here. I'm going to have, in factored form, I'm going to have an x plus 2. I'm going to have just a plain old x as well, kind of an x plus 0 or an x minus 0 if you want to think of it that way. And then I'm going to have an x minus 4 on the other end. So again, the numbers that are my zeros, when plugged into my equation, will calculate out to a 0. So if I put a negative 2 into the first bracket, I get negative 2 plus 2, which is 0. If I put that same negative 2 in all the other parts, I end up with 0 times negative 2 times negative 6. I plug it in, I get 0 times the negative 2 times negative 6, which is 0. That's what a 0 means. I'm getting a 0 on my graph for the y value. When I put that x value into my equation, I get a y value of 0 as well. Yeah, so that's basically the end of that one. It just asks us for the x-intercepts. They are given to us here, -2, 0, and 4. And the factors of would be x plus 2, just plain x, and x minus 4. And then I did say not to do this question, but in case I change my mind in the future, or in for in the interest sake, the only reason I didn't want it in there was it was just kind of the answers are a little bit confusingly written. The intervals where the function is positive and negative. Positive, positive, negative, negative. So it's literally asking you where the y values are positive, where the y values are negative. You want to think about any function you ever see, the x is just a placeholder establishing kind of what we're going to, or where we're working, let's say. And the y value is the actual function value. It's the important one. It's the one we calculate. It's the one that matters. It's the one that makes a difference. If I look at my x values on a graph, I'm getting, as I go left to right, because that's how we tend to read, the values go up by 1 or up by half, or however, whatever process we're using to count. But the y values can change drastically. They go up and then come back down and go back up again, or do a little flattening at some point possibly and then bounce back. So the y values are always the ones we're interested in. So here the intervals are basically just asking us that. And how they are written, I don't even remember, but it could be something like our values are negative when x is less than -2, or 0 is less than x is less than 4. So that's sort of the negative section. The x values are less than -2, or x values between 0 and 4. And then similarly for the positives. Okay, so again, I didn't really ask that, but that's really all the question was asking when it asked for the intervals that are positive or negative. And I won't go through B because it's basically the same thing.